Okay, let's talk a little bit about predicting chemical reactions. So, if you're given a set of substances and asked to predict the chemical reaction that will occur between the substances, there's some different routes you can take to try to help you figure out what's going to happen. And one thing to consider is what we call periodicity. And so that's basically that elements in the same family or the same group on the periodic table tend to react similarly. Okay, so you could try to figure out what other like elements do in the same scenario. For instance, group one metals are all going to react similarly with things. So if one group one metal reacts a certain way, you almost always can just swap out the group one metal in that reaction with any other group one metal. Most often, then those reactions all occur. Um, and so, for instance, group one metals react with water to form hydroxide and or the hydroxide of that group one metal and hydrogen gas. Okay, no matter the group one metal, the same thing's going to happen. You're always going to have that group one metal here. I've got lithium and sodium and potassium shown, and each one of those reacting with water form their hydroxide. So lithium hydroxide when lithium reacts with water, sodium hydroxide when sodium reacts with water, potassium hydroxide when potassium reacts with water, and then also hydrogen gas. Okay. And so if you know how one element in a group or in a family reacts with something, it's very likely that the other things in that group react the same way. Okay, at least for main group elements or representative elements of the same type. Um, so when you're talking about the later groups in the periodic table, when some things in the group are metals and some are non-metals, you wouldn't assume that a metal does the same thing a non-metal does, because that's not probably the case. But this is useful when you're dealing with things like group one metals or group two metals or even halogens, because pretty much the whole group then is going to behave the same. So another example, if you have group two metals are going to react with oxygen gas to form oxides. So it doesn't matter which group two metal you're talking about. So I can just give you some common ones here: magnesium, calcium, and barium. Each one of those would react with oxygen gas to form their oxide. So magnesium with oxygen gas forms magnesium oxide. Calcium with oxygen gas forms calcium oxide, and barium with oxygen gas forms barium oxide. Okay, and so you essentially, if you have the reaction related to one element, you could pretty much assume that you could swap out anything else in that group and you're going to have a similar reaction or the same type of reaction occur. Okay, um, and so it's not perfect, but sometimes that can be helpful, especially if, you know, you don't want to go and try to perform the experiment to see if it happens, okay? Or if you can't find anything when you try to look up what happens, okay? If you can determine what happens with other elements in the same group, it's very likely the same thing's going to happen, and you can just swap out um, a different element in the group. Okay, now another thing that you can consider is the number and type of reactants that you have reacting. Okay, to get a general idea of what's the likely kind of pattern that's going to be followed to help me figure out the products. Um, so one thing that we could have happen is what's called a decomposition reaction. That's always going to be what is happening if you're only starting with one reactant. Okay, you're starting with one reactant. The only thing that could possibly happen is that reactant breaks down. Okay, now how much it breaks down kind of depends on the reactant. Okay, It may break down completely into the elements. It may break down just into different smaller compounds. So we'll talk about decomposition reactions a little bit more in another video. Next, we have combination reactions. And that would happen when you have two substances reacting together, especially if it's just two elements. The only thing that can happen is those elements combine. Okay, now you could have a combination reaction with small molecules coming together and forming a much larger one. But most often when we're dealing with a combination reaction, it's really just one element and then another element coming together and then forming either some sort of ionic compound or some covalent compound. So I'll talk about that a little bit more in a video focused on combination reactions. Another type would be single replacement reactions. Okay, so similar to a combination reaction, we're starting with two substances. Okay, but the difference is in a single replacement reaction, you definitely have a compound and an element. Okay, so you have one thing that is attached to other things. So a compound is made up of multiple elements, whereas the other substance is just one element. Okay, and so what's going to happen in that type of reaction when you have that scenario of something by itself and something bonded to something else, they're going to in some ways swap places. Okay, so the thing that is by itself, the element by itself, will swap places with one of the components of the compound. Okay, and it's going to swap places with the like component. And so usually this is an ionic compound with an element. Okay, and if it's an ionic compound, it's made up of a metal and non-metal. So if the thing it's reacting with is a metal, the metal will replace the metal in the ionic compound. If the thing it's reacting with is a non-metal, it will replace the non-metal in the ionic compound. But that is a big hint if you just have one compound and one thing by itself, that you're likely just swapping things out. You're replacing something in that compound. And so that's kind of an indication that you would have a single replacement type reaction. Now, the last just general type of reaction that you could kind of predict from what type of substances and how much stuff you have or how many reactants you have would be a double replacement reaction. Whenever you're doing a reaction that's two compounds, especially if it's two ionic compounds, because this is most often what a double replacement reaction starts with, is you have two ionic compounds as your reactants. And what happens is they swap ion partners, okay? So each compound splits essentially into two pieces, and then they just swap partners, okay, and form two new compounds. So if you're given reactants and asked to predict products, sometimes you can get an indication just based on, well, I only have one substance. If I have one substance, I know I need to break it down. If I'm just putting together two elements, well, those two elements have to bond together. If I have a compound and an element, then that element's going to swap out for one thing in the compound. If I have two compounds, they're probably going to fall apart completely and swap around completely, okay, into two new compounds. So sometimes you can just get an idea from how much stuff you have as well, okay? But we'll talk about all these types of reactions a little more in depth in other videos.